Newton's method is really a nifty way to find the roots of an equation. However, there are times when it can go wrong, and so I'll talk about the four ways that it can go wrong in this video. So the first way that Newton's method can go wrong is when you have an inflection point. So here's the inflection point in the area of the root. And so in this case, we made an initial guess of x naught, and when we drew our tangent line, it took us over here, and then you can see we drew our next tangent line, and it actually took us to a completely different spot. If we followed that up and took the tangent line at x sub 2, it would go back over here. And what's happening, how you would see this play out when you're doing Newton's method, is you would see that your answers start to diverge instead of converge. They're actually getting further and further apart. So that's the first way that Newton's method can go wrong. The second way that Newton's method can go wrong is when you pick an initial guess that actually falls near an extrema, a local extrema. In this case, our initial guess fell on the left side of this local or relative min, and when we drew our tangent line to the curve at that point, it took us over to the other side of the local min, and then when we drew the tangent line there, do you see how it goes back to this side of the min, the left side of the min, and so on. So it's going to be oscillating back and forth around that local minimum. And what you would see, or how you would see that play out while using Newton's method, is that your answer would go back and forth and would not converge to any specific value. In this third situation, we start with an initial guess, and you can see that when we draw our tangent line, the first one comes over here, and we draw another tangent line, and you can see that it jumps far away from that root. And so that would play out in Newton's method. You would recognize that if you were calculating a root and suddenly you saw it jump far away. And finally, the fourth situation is when you either start with a guess that leads us to a second value that has a horizontal tangent line, or perhaps you even start with your initial guess and that has a horizontal tangent line. And notice if you have a horizontal tangent line, that horizontal tangent line will not intersect the x-axis. So all of these had our tangent lines intersecting the x-axis. All of the other examples had the tangent lines intersecting the x-axis so that we could create the follow-on guess. When a tangent line does not intersect the x-axis, we don't have a follow-on guess. And in fact, what you would see in the table is that you would get an undefined value. So that is your last way that Newton's method can fail. Is when you start with a value that leads us to a horizontal tangent line at some point, or we start with an initial guess that has a horizontal tangent line.